Okay, welcome back. Now I want to show us how we add a number basis. Okay? Normally in our everyday arithmetic, 1 plus 1 is 2. The same way 1 plus 1 is 2, but you remember our introductory section where I said because it's in base 2, we cannot write the figure 2 there. So what do? We go back to our usual primary school long multiple division process. So 1 plus 1 is 2. I write my 2 here. And I say 2. The base 2 is outside. How many 2 can go in 2? 1. Remainder what? 0. How many 2 can go in 2 is actually 0. 2 can go in 1 is 0. Remainder that 1 here. Are you there? So this one, we write it upwards. Pay attention. We write this figure first. 0, 1, and 0. So that is 10. So that means 2 in base 2 is actually 10. Okay? So I will write 0, carry 1. This one I will carry, add it to this 0 is 1. 1 plus 1 is still 2. That 2 will still give me 10 under long division. So I put my 0 here. Then I'll carry 1. So 1 plus 1 plus 1 will give me 3. I can't write 3 there. I will go back to my long division method. So I put my 3 inside, divided by my 2. Okay? How many 2 can go in 3? 1. Remainder what? 1. How many 2 can go in 1? 0. Remainder what? 1. So I write it in this direction also. 1, 1. So I put my 11 here. So that is my answer. It will be 1100 base 2. Are you with me? So if you are with me, then we can as well practice this. So I'm wiping off. I'm wiping off. So the same way we did base 2, I'm doing base 4. Okay? So if I add, for instance, if I say 3 plus 2 is 5, I can't write 5 here because this is base 4. So what do? I do the same long division and I use my 4 to divide. How many 4 can go in 5? 1, remainder 1. 4 cannot go in 1, so it's 0. I bring back my 1 out here. So this gives me what? 11. Pay attention, 11. So I'll write this one here, carry another 1. Okay? So that brings it here, 3. So 3 plus 3 is 6. I can't write 6 because I'm dealing with base 4. So I come here again, I use my long division. 4 in 6 is 1, remainder 2. And 4 in 1 is 0, remainder 1. This is now, if I write upward, this is giving me 12. So I'll write my 2 here, carry 1. Okay? 1 plus this is 3. 3 plus 3 is 6. 6 is also 12. So I put my 12 here and I put my base 4 down here. So my answer will become 1221 base 4. Okay? Now, which other way can I do this? Let's assume I don't want to cause problem to myself. I want to be smart. So I can as well decide to first expand each of them to base 10. For instance, if I say 101 base 2, let me convert it to base 10. So I will say 1 times 2 raised to power 0, right? Plus 0 times 2 raised to power 1, plus 1 times 2 raised to power 2. So it will give me, this will give me 1 times 1, plus 0 times 2, plus 1 times 4. Then this will give me 1 plus 0, plus what? 4. Everything will be 5 base 10. Remember? Then I will take my 111 base 2. I'll do the same thing. I'll say 1 times 2 raised to power 0, plus 1 times 2 raised to power 1, plus 1 times 2 raised to power 2. This is 1 times 1, plus 1 times 2, plus 1 times 4. That gives me 1 plus 2, plus what? Plus 4. Everything here is 7 base 10, right? So, meaning if I now say 5 plus 7, 5 plus 7 will give me what? 12. This is already 1, 2 in base 10. So I can convert it. So I'm merging this explanation with the objective, how to convert from one base to another. So if this is 12 base 10, for instance, or 12, what will I do? I will now expand it by long division. I will expand it by long division. So I will say 12 divided by 2. How many 12 can go in 2? 6. Remainder 0. How many 2 can go in 6? 3. Remainder 0. How many 2 can go in 3? 1. Remainder 1. How many 2 can go in 1? 0. Remainder 1. So I'll write it this way, upwards. So I will have 1100 base 2. You can see it's the same answer I got with this first example. That is how to, so that for those of us who panic when we see questions, oh, I don't want to make mistake, I'm afraid, this is how best to go about it. Okay, so I have merged teaching you addition to teaching you how to convert from one base to another. They can actually ask us a question, for instance. They can say, the question can be, they can say, solve or convert, for instance, 24 base 5 to base 7. How do I go about this question? I first convert it to base 10. How do I do that? I say 2 times 5 plus what? 4 times 5. I put my raised to power 0, put my 1 here. So I'm converting to base 10. So I'll have 2 times 5. 5 raised to power 1 is 5 plus 4 times 5 raised to power 0 is what? 1. This is 10 plus 4. What did I get? I'm getting 14. This 14 is actually in base 10. But they say leave your answer in base 7. So what do I do? By long division method, I put my 14 here and I divide by 7. How many 7 can I say in 14? 2. Remainder 0. How many 7 can I see in 2? It's not possible, so I put my 0, remainder that 2 here. So if I write upwards, my answer will actually be 20 base 7. So meaning that 20 base 7 is the same thing as saying 24 base 5. Thank you. So I have achieved that now by using that division, this same method to answer, to treat how to convert from one base to the other. Okay? Can you all see this part of the board? I want you to go through it on your own and check. I need you to also show how we got this 12 to link us to this. You can do that in the same way and show me at the comment section, but we are not done yet, okay? So without wasting time also, kindly let's treat subtraction. Let's treat subtraction so that it treat subtraction now. How we can evaluate subtraction. This is simple, the same way. So let's look at subtraction. So if I say 2, 4, 4 base 6, for instance, subtracted by 1, 5, 4, or 1, 5, 5 base 6. Okay? Now, the same way we do our usual subtraction in arithmetic, that's the same way I will still do. Okay? Now, can we take 5 away from 4? The answer is no. We can't do that. So I borrow 1 from here. The 1 I borrow here, change this one to 3. Are you with me? So if this one becomes 3, that one I borrow is actually 6. So that 6, I'll add it to this 4 here. That makes 6 plus 4 gives me 10. So 10 minus 5 gives me 5. Okay? So this is 3, right? Can I take 5 away from 3? The answer is no. So I borrow 1 here. That one I borrow now is actually 6. So 6 plus 3 makes it 9. Makes it 9. Because this one has reduced now to 1. So 9 minus this 2 is 9. 9 minus 5 will give me 4. And 1 minus 1 is 0. So this will be 45 base 6. Now, let's also look at another one. Okay? JAMB can choose to ask you anything. They can give you different bases and tell you to add or subtract. So what is the shortcut? For instance, if you were given something like this, maybe 1, 2, 1 base 3, subtracted by from 1, 1, 1 base 2. Okay, you can see both of them are in different bases. They are both in different bases. So what do? We can decide to convert each of them to base 10, subtract. If they do this, they will always tell you leave your answer in base, maybe base 4, for instance. They say leave your answer in base 4. So what do? I first convert everything here in base 3 to base 10. So I will say 1 times 3 plus 2 times 3 plus 1 times 3. This is 0 raised to power 0, 0 power 1. Then this will be 1 times 3. Sorry, this is raised to power 2. 1 times, this will be 1 times 9 plus 2 times 3 plus 1 times 1, because 3 raised to power 0 is 1. So this gives me 9 plus 6 plus 1. This will give me 16 minus, I will come here again. I'll change 111 base 2 to base 10. So what do? I say 1 times 2 plus this 1 times 2 plus this last 1 times 2. So I'll put my index 0 here, 1 and 2. Okay? So what next should I do? I will say 1 times 4 plus 1 times 2 plus 1 times 1. This gives me 4 plus 2 plus 1. Everything here is what? 7. So I now have 16 minus 7. That gives me what? 9. Everything still in base 10. But the question says, leave your answer in base 4. So what do? The same way, I rule my line. I put my 9 here and I put my 4 here. How many 4 can go in 9? How many 4 can go in 9? 2, remainder 1. Can 4 go into no? So this will be 0, remainder 2. So I write it upward. My answer is what? 21 base 4. So my final answer to this will be 21 base 4 as required by the examiner. So in this slide, I have successfully shown us how to navigate from one base to another. Finally, the final slide, I want to show you how we can do multiplication. Now, the multiplication can also be done the same way. If I say 1, 1, 1 multiplied by 1, 1, they are all in base 2. 1 times 1 is 1, 1 times 1 is 1, 1 times 1 is 1. 1 times 1 here is 1, 1 times 1 here is 1, 1 times 1 here is 1. Okay? So if I add 1, if I add these 2, 1 plus 1 is 2. I can't write 2 here. 2 is 10. We showed you before how we got 2 to be 10. Okay? So if 2 into 2 here is 1, remainder 0. 2 here is 0, remainder 1. So it's 10, right? So I write my 0 here, carry 1. So 1 plus 1 plus 1 is 3. So if I convert 3 also to base 2, for instance, it will give me 2 in 3, 1, remainder 1. 2 in 1, 0, remainder 1. This is 11. So I put 1 here, carry 1. 1 plus 1 is 2. And 2 is already 10. So that will be my final answer if I'm multiplying. Now, if you can as well see first change to base 10 and change this one to the base 10, multiply the two together like normal multiplication, and now convert to base 2 as required in the question. Now, there is a part that rarely comes out, but I will still want to touch it so that it can be of advantage to people. Now, for instance, if you have a decimal point in the given equation, you can still solve it. How do we solve questions of binary numbers or number systems that has decimal points? For instance, if I have a question like this and I say 1.01 base 2, the same way, I will come here and say my what? 1 times 2. I will come here and say my 0 times 2. I will come here and say my 1 times 2. I will come here and say my 1 times 2. This is, now, you remember, there is a point here. If this point was not there, I would just start, I'll put my 0 here and my 1 here. Because this point is there, so this one will be minus 1. You know, when you are treating graph, when you are treating graph, the midpoint of any graph is 0. From here, I will have 1, but this other side, I have minus 1. And if I'm going this direction, I will keep having minus 2. So this one will be minus 1. This one will be minus 2. So what I will now have will now be 1 times 1 all over 2 raised to power 2, according to indices law that we treated before. Then this other one will be 0 times 1 all over 2 raised to power minus 1, which is now raised to power 1. Then this one will give me 1 times 1, and this one will give me 1 times 2. This answer here will give me 1 times 1 over 4 plus 0 times half is 0. 1 times 1 is 1. 1 times 2 is what? 2. So what will be my answer? This will be 1 plus 1, and 2 plus 1, 3. Plus 1 times quarter will now be 3 whole number, 1 over 4. That will be my final answer. Or you say 3.025. So let me see. 4. I have my 1 and I have my divided by my 4. So 1 here, 10. Okay, 3.25. It will give me 3.25 as my final answer. Please carefully follow it, go through it, and ensure that you bring all of them together. And trust me, any question on number system, no matter the basis, you are good to go. See you in the next video and the next topic. I remain your mathematics guru. Join me, share this video, like, and give me thumbs up. Make sure you share the video to every of your contacts. Thank you.